School of Chemistry at the University of Birmingham currently has 27 research groups, and many of them work in the area of sustainability. This has many aspects and can include sustainable use of resources, the search for greener processes, and recycling.
The carbon dioxide is an important heat-trapping greenhouse gas, and its accumulation in the atmosphere results in an increase of the global temperature. Global climate change has already had observable effects on the environment. Glaciers have shrunk, rivers and lakes are drying up, more intense heat waves, and the hurricanes are getting stronger and more intense. Worldwide, it is recognized that recycling carbon dioxide to fuels and other high added value chemicals is a key element towards sustainable low carbon economy. At the School of Chemistry in Birmingham, we aim at developing novel catalysts and electrochemical methods for the electrochemical recycling of CO2 emissions into liquid fuels with high efficiency and selectivity. Our research tried to mimic nature and produce artificial photosynthesis in which we can produce liquid fuels from a combination of sunlight, water, and carbon dioxide. CO2 recycling will play a vital role in worldwide efforts to limit global warming and will allow us to deliver on the fifth of the emission reduction needed by 2050.
My research is focused in the area of plastics. Plastic waste is a huge problem that faces society, and there are multiple solutions that are going to have to be applied to change the way that we deal with plastic waste. My group are focused in two main areas. The first is in looking at using sustainable feedstocks to replace current petrochemical feedstocks. In particular, we're focused on creating new sustainable materials from plant-based resources that have the same properties as the plastics that we're already using. The second is in chemical recycling and chemical upcycling of plastics to create added value chemicals, additives and materials. Mechanical recycling leads to degradation of the polymer chains. This leads to a downgrading in the performance of that material. Chemical recycling means that we can depolymerize the plastic back to its constituent monomers, which then when repolymerized gives you the virgin material that has the same performance as it had at the start.
The European Chemical Society recently published a periodic table with a traffic light system denoting how at risk certain elements were of short supply. And of the 92 naturally occurring elements, less than half, only 44, were actually rated as green. Many of these elements are actually used in modern technologies. For instance, if you have a smartphone in your pocket, you're actually holding perhaps 25 to 30 elements, and as many as 20 of those might actually be at risk of short supply. In the Birmingham Centre for Strategic Elements and Critical Materials, we're taking a four-pronged approach to try and address issues of materials criticality. One is regulation, one is reduction of the materials through more efficient design. The more chemical ones are of course trying to replace the materials, and very, very important as we go forward in the future of course will be recycling. A good example of one of our projects is the ReLib project, which is dedicated towards setting up a UK lithium-ion battery recycling industry. At the moment there are actually no facilities in the UK for recycling lithium-ion batteries, so that not only potentially causes an issue of waste and safe decommissioning of the vehicle batteries, but it also gives a big opportunity to recover these elements and actually start up a manufacturing facility in the UK.